In this video, I'm going to introduce a couple strategies for simplifying trigonometric expressions. So our goal in this section is going to be taking a complicated expression and turning it into a shorter, smaller expression using some identities given over the next few slides. I will point out that there is no one method for doing these. Many times you kind of have a choice in how you approach the problem and which substitutions you make, but some methods will end up being shorter or taking less steps. That doesn't mean the other method is incorrect, though. The first strategy we're going to look at is for rewriting expressions using sine and cosine functions. The thing to look for is any cosecants or secants in the problem that you're given, and rewrite them knowing that they're the reciprocal of sine and cosine. So every time you see a cosecant, replace it in parentheses with the fraction 1 divided by sine. And every time you see a secant, replace it with the fraction 1 divided by cosine. It's also true that the reciprocal of these works, so 1 over cosecant would be equal to sine, and 1 over secant would be equal to cosine. So you could flip the expressions given in these fractions and they would still be true. And we have some similar statements for tangents and cotangents. So whenever you see tangent, replace it with sine over cosine, and whenever you see cotangent, try replacing it with cosine over sine. Over the next couple of slides, I'll show you some examples of how that might simplify things by causing terms to cancel out. So here's our first example where we're going to try to simplify cosecant of x times tangent of x. Now right now I don't see anything that factors or cancels or does anything on its own, so we're going to try the strategy of changing things to sines and cosines. If you look back at the previous slide, I indicated right here that cosecant of x is equal to 1 over sine of x. Well, if those two things are equal, then I can replace one with the other, so I'm going to write, instead of cosecant, 1 over sine of x. Similarly, I have tangent of x, and again on the previous slide, I indicated that tangent of x is equal to sine over cosine. So that's another substitution I can make. I can replace one with the other. So instead of tangent, I'm multiplying by sine over cosine now. Now I will point out that I see a lot of students leave off the variables, but these are important. Do not just stop writing the x's or the y's or the thetas or whatever variable you have in the problem. We do need to include them because they have sine, cosine, and tangent have no meaning without the other variable or numbers filled in there. So now I've replaced cosecant times tangent with 1 over sine times sine over cosine. Well, a nice property we have for multiplying fractions together is that when you have the same thing in the denominator and the numerator of the fractions, then those will just cancel out because it's like I'm saying sine of x divided by sine of x, or 7 divided by 7. So since that cancels out and leaves us with 1s, now I have 1 times 1 over 1 times cosine. So we've already gotten it down to just one trig function instead of multiple trig functions. So that is simpler, but there's one more thing I could do to make this look even nicer. That would be to get rid of the fraction in its entirety. So remember that 1 divided by cosine is the same as secant. Since these two functions are reciprocals, having cosine in the bottom is the same as having secant of x over 1 instead. So if 1 over cosine equals secant, then we would consider it more simplified to just write secant of x. That way we have one trig function and no fractions in our answer. So here we have simplified the statement cosecant times tangent by changing things to sines and cosines and then seeing if anything canceled out or reduced from there. Here's another quick example, but I'm going to go a little bit faster this time. So I have a cosine of x. There's nothing I can replace that with. I just want to leave that as cosine of x. The strategy we're testing right now is changing the other expressions to sines and cosines. So I still have cosine of x, but instead of multiplying by tangent, I'm going to replace that with sine of x over cosine of x. And then I have plus sine of x, which again, I can't do anything to. It's already in terms of sines and cosines. It may help you to think of this as cosine of x over 1 for a second, because the same thing is happening that it did in the last problem. I have a cosine on top times a cosine in the bottom, so the cosines would cancel. Cosine divided by cosine is 1, which means this product is now just equal to sine of x over 1. Now I still have this other sine of x, and the rules for adding sine of x and sine of x together is the same as adding x plus x. X plus x equals 2x. So since I have the same exponents and the same trig functions, I can combine these like terms, sine of x plus sine of x, would be equal to 2 sine of x's. So that would be our simplified answer in this case. Again, we changed any expression that wasn't in terms of sine or cosine into sines and cosines, and then we saw if anything canceled out by either factoring or cross-canceling, dividing, whatever the case may be. Here's the second strategy we're going to cover for simplifying problems today. These are what we call the Pythagorean identities. And the first and most important one is that sine squared of x plus cosine squared of x will equal 1. The other identities are also important, but this is definitely the one that gets used the most. So the way we will use these is we're going to look for trig functions that have the second power. So when you see something like a sine squared or a tangent squared or a secant squared, whenever it's a trig function being raised to the second power, you're going to look to see if there's any kind of a substitution you can make here. For example, if you see both sine squared plus cosine squared, you could replace that whole part of the problem with just a 1 instead. I do want to emphasize that these identities only work for the second power. You can't change these to the first power or the third power and still use any of these properties. They only work exactly as written in terms of the exponents. However, something you can do to the problems is to add and subtract things from one side to the other. So don't change the exponents, but if you want to do something like take this first property, sine squared plus cosine squared equals 1, it is true that you can subtract cosine squared from both sides of the equation here. So if you do it on the left side, you have to do it on the right side as well. That would leave me with sine squared, and then the cosine squared minus cosine squared would cancel. And on the other side, these are not like terms, 1 minus cosine squared. So I would just write those out separately as 1 minus cosine squared. So it is important to notice that I can replace sine squared plus cosine squared with 1, but it also may be useful to just replace sine squared with 1 minus cosine squared. Or the other way around, you may have 1 minus cosine squared. You may want to try replacing that with sine squared. So every time you see expressions being raised to the second power, especially if you see a plus or a minus 1 in there with them as well, that's a good indication to look at your Pythagorean identities and see if there's a substitution that can be made, which will maybe set up some other factoring or canceling. So here's our first example. Now the other strategy I showed you was to change things to sines and cosines and see if that makes everything cancel. But sometimes that doesn't help you, because in this case, I don't have any secants, cosecants, tangents, or cotangents. So that strategy won't be of any use to me in this problem. However, I do see some expressions being raised to the second power, and I see that there's a plus or a minus 1 attached to it. So that's the hint to me that I should look at my Pythagorean identities. Now, even though I don't see an identity that matches it exactly right now, remember I told you that we could add and subtract things from one side to the other. In fact, I showed you that by subtracting cosine squared from both sides of the equation, you end up with 1 minus cosine squared is equal to sine squared. So since these two things are equal, we can replace one side of the equation with the other. And that's what I'm going to do in this problem, because we have a 1 minus cosine squared. So I'm not doing anything to the first part, the sine of x, but then I'm supposed to be taking sine of x and multiplying it by 1 minus cosine squared, which I just showed you is equal to sine squared. So now we have sine times sine squared, and just like if you have x times x squared, the rule in this case is that you add the exponents, so you would get x cubed. The same thing is happening here. Since I have the same trig function, sine and sine, you just add the exponents. The first power and the second power will make it the third power. And that's as simplified as this could get. I'm going to leave it as sine cubed of x, which is easier than this original expression I had. Here's one last example where we're going to try to simplify all of these things being multiplied and added together. Now in this particular problem, before I even go to look at any of the identities, I want us to notice that we have cosine of x in this term and cosine of x in this term. Our terms are separated by plus and minus signs, so both terms have a cosine of x in them, which means I can factor that out. There's a greatest common factor here. So if I take cosine x out of cosine of x times tangent squared, I'll get rid of the cosine part, but I'll still have the tangent squared of x part. And then if I take cosine of x out of cosine of x, that leaves behind a 1. Common mistake being that people often put a 0 down here. but when I factor something out, I'm actually dividing by cosine of x. So cosine of x divided by cosine of x is equal to 1. Now this is a problem where I could try changing things to sines and cosines and see if anything cancels out, and that would probably still work. It might take more steps, but what I'm going to show you instead is that I have a trig function to the second power, so I have something squared, and there's a plus or a minus 1 in there, so I like to look back at our Pythagorean identities again. So in this third line right here, I see that tangent squared plus 1 is equal to secant squared. I don't need to do any adding or subtracting from one side to the other because this is exactly what I have, tangent squared plus 1, which means I can replace that whole expression with secant squared instead. So I'm not doing anything to the cosine of x. I still have cosine of x times something, but I'm replacing everything inside parentheses with secant squared of x. Be careful about your exponents. It should still be the second power. Now this is almost done, but at this point, I'm going to point out that secant is the reciprocal of cosine again, just like we did earlier. So I'm going to leave cosine as is, but replace secant squared with 1 over cosine squared. And since this counts as cosine of x over 1, I have a cosine canceling from top and bottom, just like if I had x over 1 times 1 over x squared. That'll cancel one of the x's out from top and bottom, but it'll still leave me with one of the cosines in the bottom. And again, instead of writing a fraction, as long as you remember that cosine is the reciprocal of secant, then you could just leave that as secant of x. So now we just have one trig expression as our final answer. It turns out that one function, secant of x, is the same as this whole expression we had originally. So by writing a series of equivalent statements and performing some identity substitutions in there, canceling out whenever possible, we were able to simplify the problem considerably and make it just this one thing instead for our answer. So that's it for the notes. Thank you, guys.